Hey, I'm Mitchell and welcome to another video in the RSP Education series. Ever wonder how a tiny electrical signal can turn on a huge motor or machine? If you like this kind of content and want more educational videos, like and subscribe. Also, this video is for educational purposes. Consult a professional for your application. RSP Supply is not liable for any misuse of this information. With that said, let's dive in. So what is a relay? A relay is basically an electrically operated switch. It lets a low power electrical signal control a much higher power circuit. Think of it like a gatekeeper. It listens for a certain signal and then it either opens or closes a gate, or in this case, a circuit. Relays have two main parts. First off, the coil. That's an electromagnet that generates a magnetic field when it's energized with electricity. Then you got contacts, and these are metal switches that move open or closed based on the coil's magnetic field. So when power flows through the coil, it creates a magnetic field that pulls or pushes the contacts, which changes the state of the circuit, either turning something on or off. You can use a small control signal, like from a sensor or PLC, to switch big loads, like motors, pumps, or lights. Let's talk about the relay's history. Early days, relays go back to the early 1800s. First used in the first telegraph systems, they allowed weak signals to be re-amplified across long distances. Think of them as signal boosters for communication. Then came the Industrial Revolution. By the early 1900s, as industries added electrical control systems, electromechanical relays became very common. They controlled motors, heating elements, lights, you name it. They were the brain behind many control panels before PLCs, programmable logic controllers, existed. Now we're talking modern era. Today, there are solid-state relays, SSRs. These do the same job without moving parts. They're faster, quieter, and longer lasting, but can be more expensive and heat sensitive. Still, traditional mechanical relays are widely used because they're cheap, reliable, and easy to troubleshoot. The reason why relays matter so much in industrial control, starting off with isolation. They isolate control signals from high-power equipment that's potentially dangerous. This protects delicate electronics like PLCs and sensors from big voltage spikes. Remote control is another big asset. You can control heavy-duty equipment like, let's say, a 50-horsepower motor from a safe distance using low-voltage control signals. This makes things safer and easier. Logic control. Before PLCs, relay logic, called relay ladder logic, was how industrial machines operated. It's literally a series of relays wired together to perform logical sequences like start, stop, delay timers, interlocks, etc. Flexibility is another big pro with relays. They are easy to replace or rewire. In small plants or simple machines, they're often preferred over PLCs because of low cost and simplicity. Fail-safe design is another big boost. Relays can be set up to default to a safe state, usually off, if power is lost. This is critical for industrial safety systems. Bottom line is that relays are a powerful force within industrial automation. Whether you're running a motor or lighting up a warning lamp or even interlocking a safety gate, there's probably a relay involved somewhere in that system. Even with the rise of PLCs and smart systems, relays are still essential tools for control, protection, and automation as you're going to keep on learning in the series. That's it for today's introduction onto relays, folks. Thank you for joining. Please visit our website at rspsupply.com for any relays or hundreds of thousands of other industrial automation products.